No question. Okay, so if you don't have any question, let me review about the last class. We you have everything in the module 3 here. So we're going to talk about the program development cycle. You have a 4 major step. You have analyze problem, you have design problem, you have a course program, and you have the test program here. And the first one is the analyze program here. You always have to be very specific, right? Very specific, and work in the detail here. So the first thing you always have to identify what are the expected output, right? And from the expected output, you're able to figure out what are the input you need in order to produce the expected output here. So think about, you have the requirement to figure out what is the area of the rectangle here, right? So if you think about the output here, you have area. It's the area of the rectangle. And so in order to figure out the area, you need to know what is the length and what is the width here, right? So this is input here, you need the length and you need the width here. Okay, so basically for everything in the analyze problem, you have a very specific, and you have to try to figure out what are the expected output, and from the output, what are the input in order to produce the output here. So when you figure out the output and input here, you have to name for it, right? So for this one, you set the name, area, length, and width here, and you also have to identify what's the data type here, data type. So some of the programming language, they require you that you have to declare the variable before you use it. So when you identify what the variable name and what the data type, you're able to declare them, right? So see for this one, see you have declare here, declare as area, length, and width at a float, something like that, right? So once you figure out the output and input, the variable name and data type, you also have to figure out the formula here, right? So for this one, in order to figure out the area, you have to set the area here. You know that in order to figure out area, you have to set equal to length times width here. So basically in the analyze problem, you always have to very specify what is the requirement here, right? So the second one is the design, the program here. So in the design program, you can use the chart here. The chart you see in the chart here, you can use the flow chart, right? Can use a flow chart, or if you're working with the modular structure, you can work with the hierarchy chart. You know that in the case that if you want to break it down, the program into multiple sub-module here, you have to work in the hierarchy chart. So you have the main module. You have the main module here, and you able to break it down into the sub module here. So it's up to you. It can be 2 or 3 or 4 or 5. It's providing that it's convenient to you. And for each of the sub module here, you are able to break it down. Furthermore, you think about if you have a complex programming, you're able to break it down into multiple sub module here. So the chart here, you're able to use a flow chart or hierarchy chart here. Hierarchy chart is in the case you're working with the submodule here, modular structure. Right? And you can use a module. You can use a model here. The module here is we will study today. You working with the UML here, right? Unified language here, and or you can work with the ordinary language. It's a pseudocode here. So in this one, you also have to identify the algorithm need. The algorithm is someone is well-defined, well-ordered, must produce some results, and must terminate in the finite time here. Okay. So when we look back on the programming development life cycle, the two major steps is always analyze and problem here. So we always to tell that you have to place enough time, you have to very specific and work in detail when working with analyze and design program here. So when you have the well-designed program with the flowchart or pseudocode or the model here, you can translate it into the coding here. It just translates it into coding. So for For this class, you just translate it by working with Raptor. But remember, the Raptor is not the programming language. It only is the simulation only. Right? So in the real life, you can translate it into the real programming language. So you can translate it to the C# or Python, whatever it is. But the thing is that once you understand the logic of the pseudocode or flowchart, it's very, very easy for you to translate it into the specific programming language here. And for each programming language, they use specific syntax here. And that's one you also have to pay attention to that here. And in the coding, you're able to use the external documentation or internal documentation here. So for external documentation, it's very, very helpful for the programmer, for the coder here to understand, to follow the coding. Because if you think about, if you have very, very complex the software or the program, it's very, very long and very hard to follow. So it will have a benefit if you have put some of the internal documentation. It can be the header comment or inline or step comment here. For the external documentation, it can be the user guide. It can be help. So it helps the end user to understand more about the program here. Okay. The last one is the test program. So basically in the design program here, in the design here, you also have to list out what is a testing step here. So think about, if you think about the when you want to develop a program to figure out what's the area of the rectangle. So in the design program here, you also have to set, you have to figure out what is testing scenario here. So you think about what happens if I enter the length here is 10 and I enter the width here 5 and I expect the output here 50, something like that, right? That is something about the testing, and you have to figure out the testing scenario in the case when working with the design program here. So for the test program, you just follow the dash checking when you're working in the design here. So you come back to the testing scenario into the design. You enter what is the width, you enter the plan, what is the length, and you do the file, and you see what is the output here. If it's a 50 here, so we can see that is the output is what you expected here. Okay, so you have the sum of additional step in the cycle. And remember one thing about cycle here. The cycle that everything that you are able to come back to modify or to change anytime, right? That's why the code is a cycle here. Okay, so we have some additional step in the cycle. You can create the outline, you can have some detail, you can create the user guide or the help file, or you can change the employee to provide the telephone or web-based customer support. You have to duplicate this and for distribution, and you have to advertise program here to draw more buyer here. And remember, it is a process. It's a process, and it's a cyclical process. That means anytime if you want to go back to modify, you are free to go, right? Okay, so one thing in the design here, you're talking about the modular program, right? So modular programming, that means you break it down from the program here, you break it down into multiple submodule. And in the module here, again, you are able to break it down into submodule here. And it's up to you. It's up to you if you are the programmer or if you are the software engineer. It's totally up to you. How many submodule you want, in providing that it's convenient to you here. And remember that here you have the something definition with the module here. The module it's a perform a single task. It's a single, and it is a self-contained and independent. That means it's not, you have nothing to relate to other one here. So it's self already the program, and it can run it by itself here. So it is a self-contained and independent here, and normally it's very short here. And when working with modular programming here, you have a lot of benefits. The first one, it's easy to read. So you think about, you break it down into complex program into the submodule here. It's very easy for you to understand of each what is the meaning of each module here because each of them is self-contained and independent. So when you look on the coding of this one, you can understand what is the purpose of this module here. Right? So it's easier for design, code, and the test program module at a time. And the different program can be designed or called by different program here. You think about when you break it down into submodule, you have multiple teams and they can do it parallel. And some of them they are very good at this kind of module. Some of them they specialize on this one, and some of them they specialize on this one here. And when you develop in the modular structure here, a single module can be used for more than one time, right? So we can, if you want to use it again, you just code it again. So we see you only need to coding it. You only need to code it one time, but you are able to code it to use it for multiple times here. And for modular, not only use in one program, you can code it from the another program here. Okay, so here is an example of the modular. See, in this one, you break it down into three submodules. You have the input data, you have perform calculation, and you have an output here. So we see once you already define the module, whenever we want to use it, you just use the code here, code them here. Okay. And when working with the modular structure, you're working with the hierarchy chart here. You see you have main module, break it down in the module, and again, break it down in the submodule here. Okay, for the coding and documenting and testing, the coding is that you translate it into the specific programming language, right? So in this one, we working with the router here. For the documenting, you can have the internal documentation or external documentation here. So for internal, you have two types. The first one, the header command at the beginning of the program and provides the general information. And step here or inline the command, it helps you to understand more about the meaning of the coding here. But remember, every command, when you execute by the computer will ignore it. So from the computer point of view perspective, they don't see any benefit with the command. But if you are the programmer, if you are the software engineer, it gives you a lot of benefit because you think about the long coding here. And when you look at the step command or header command, you understand what is going on here. It's very easy for you to follow. Right? So you think about this one is a header command here. And this one, they are the step command or inline command here. That's the testing. You have the two type error. You have a logic error and you have the syntax error. That's you have. So remember, the syntax error is something that when you execute, the program will stop and it's giving you the error notification here. So we had to find a way to correct it. But the logic error, it runs smoothly, but the output is not what is expected here. Okay, so for structure programming, normally you have the three common structure. The first one is sequence. That means do step by step from the beginning to the end. You have repetition. That means you have a loop here. So you have the condition. If it's correct, do it again, do it again, do it again, do it again until it's not correct here. Or you have a selection. That means working in the branch. Again, you have the condition here. If yes, do something. If no, do something here. Okay. And you can work in the flowchart. You have the sum symbol here, your terminator starting or ending. You have process, everything about the calculation here, assignment here. You have input and output. You have decision here, yes or no here, and you have connector. And for this one, you see this one here is a pseudocode, and this one here is a flowchart. It's up to you. Sometimes you want to use a pseudocode, or sometimes you want to use a flowchart, or you can use a combination of them. It's up to you. Okay. Okay, so that is a review of this module here. Now, let me go back to the. I think let me go to this one. Any questions so far? Let me know.
So what is connector used for?
The connector is in the case that you interconnect some of the module together. So if
Okay.
you see this one is the basic here, you don't see it, but some of them sometimes you use it. Sorry. Any question? Any other question?
Yeah, I'm good now. Thanks.
So for module 3 here, you have the discussion board here. So in the discussion board here, you have something to read about the unified magic language here. Right? So if you look on, let me see. Okay, so this one is you have some information about introduction to unified modeling language. So you have some information. This one is not really. Okay, so you have the UML here is the unified modeling language. So basically, for this for some of the basic programming, you don't have to use it. Very simple, right? So it's identify what is the output and input, and you have the formula and do it very simple. But you think about if you have very complicated or huge program here, normally you have to break it down in modular, and you can use the flowchart or the pseudocode in the design, or one of the things is that you can use in the modeling here. It's unified modeling language here. So it break it down into structure, and it show you how they relate them together and how they connect them together. It's very helpful for the software engineer to look into it and translate it into the design and the coding here. Okay, so here's some of the information about this one. Basically, they break it down into major category. It's a behavior diagram and structure diagram here. And for each of them, they break it down into multiple diagram. So normally you have a lot, 14 some of them. Okay, but for this class here, normally you just focus on the case diagram here, in the case diagram. So I think it should be better for you to watch the video here. Can you hear it?
No, sorry.
No.
Okay, so I think this one I don't have the audio over there. So let me open this one.
Hi, my name is Chloe, and I'll be teaching you everything you need to know about UML use case diagrams. We'll start with a high-level overview, then we'll talk about systems, actors, use cases, and relationships. And finally, we'll build an entire use case diagram together and go over examples to explain these concepts in depth. Have you ever had an idea that makes perfect sense in your head, but when you try to explain it to someone else, they're completely lost? Maybe your idea is for a new app, and every time you talk about it, people don't really understand how they'd interact with the app or what it would do. This type of scenario is where a use case diagram is very helpful. Here's a simple description of a use case diagram. First, it shows a system or application. Then it shows the people, organizations, or other systems that interact with it. And finally, it shows a basic flow of what the system or application does. It's a very high-level diagram and typically won't show a lot of detail, but it's a great way to communicate complex ideas in a fairly basic way. Before we really get into the tutorial, let's talk about how you're going to make a use case diagram. You can draw them out with pen and paper, but a diagramming application is going to be much easier. Today I'll be using Lucidchart, and you can too, for free actually. Just click the link to access Lucidchart's website. Enter your email address, and you'll have a free Lucidchart account in just a few seconds. It's easy to use, and you can follow along with me as we build a use case diagram. Okay.
So for in this class, you can use the draw.io here.
So we're going to break down use case diagrams into 4 different elements: systems, actors, use cases, and relationships. Let's start with systems. A system is whatever you're developing. It could be a website, a software component, a business process, an app, or any number of other things. You represent a system with a rectangle, and you put the name of the system at the top. We're going to build a use case diagram for a very simple banking application. We'll call our system Banking App. This rectangle helps define the scope of this system. Anything within this rectangle happens within the banking app. Anything outside of this rectangle doesn't happen in the banking app. The next element is an actor, which is depicted by this stick figure. An actor is going to be someone or something that uses our system to achieve a goal. That could be a person, an organization, another system, or an external device. So who or what is going to be using our banking app? The most obvious actor is a customer. We are going to have customers that download and use our banking app. Another actor that we'll want in our diagram is the bank. The bank is going to provide information that feeds into our banking app, like transactions and account balances. Here are a couple things to keep in mind when dealing with actors. First, it's important to note that these actors are external objects. They always need to be placed outside of our system. Second, actors need to be thought of as types or categories. For our banking app, an actor isn't going to be a specific individual or a specific organization. We won't label our actors as John and Chase Bank. We want to keep things categorical. So right now we're saying that both customers and banks are going to use our app. And this brings up the topic of primary and secondary actors. A primary actor initiates the use of the system, while a secondary actor is more reactionary. So in our example, which actor is primary and which actor is secondary? The primary actor is customer. The customer is going to initiate the use of our system. They're going to pull out their phone, open up our banking app, and do something with it. Bank, on the other hand, is a secondary actor. The bank is only going to act once the customer does something. If the customer goes on the app to see how much money is in their account, only then does the bank engage with our system to provide the balance. Primary actors should be to the left of the system, and secondary actors should be to the right. This just visually reinforces the fact that customer engages with the banking app and then the bank reacts. The next element is a use case, and this is where you really start to describe what our system does. A use case is depicted with this oval shape, and it represents an action that accomplishes some sort of task within the system. They're going to be placed within the rectangle because they're actions that occur within the banking app. So what is our banking app going to do? We're going to keep things very simple. Our banking app is going to allow a customer to log in, check their account balance, transfer funds between accounts, and make payments towards bills. So if this is what our banking app does, we're going to have use cases that describe each of those actions. We'll have a use case called login, another called check balance, another called transfer funds, and finally make payment. You can see that each of these use cases starts with a verb and reinforces an action that takes place. We also want them to be sufficiently descriptive. If this use case just said transfer, that'd be too vague. Finally, it's good practice to put your use cases in a logical order when possible. That's why we put login at the top. That's the first thing that will happen when a customer uses our banking app. The final element in use case diagrams are relationships. An actor, by definition, is using our system to achieve a goal. So each actor has to interact with at least one of the use cases within our system. In our example, a customer is going to log into our banking app. So we draw a solid line between the actor and the use case to show this relationship. This type of relationship is called an association, and it just signifies a basic communication or interaction. A customer is going to interact with the rest of these use cases as well. They're going to check balance, transfer funds, and make payment, so we'll draw solid lines out to each of those as well. Secondary actors will also have relationships. Remember, each actor has to interact with at least one use case. So which use cases will the bank interact with? When a customer wants to check their balance on the app, the bank is going to provide the correct amount. Let's draw a line between bank and check balance. Similarly, when a customer wants to transfer funds or make a payment, the bank is going to follow through with those transactions. We don't need to draw a line to log in because that process happens within the banking app. There's no need for the bank to actually get involved with the login process. There are three other types of relationships in addition to association. There's include, extend, and generalization. Let's build out this diagram with additional use cases in order to explain these types of relationships. When a customer types in their login information, our banking app is going to verify the password before completing the login process. But if the password is incorrect, the banking app is going to display an error message. So let's create two new use cases for verify password and display login error. When a customer wants to transfer funds or make a payment, our banking app is going to make sure there's enough money to complete those transactions. So we'll also create another use case called verify sufficient funds. And finally, when a customer wants to make a payment, our banking app is going to give them the option of paying from either their checking account or their savings account. So we'll create two more use cases called pay from checking and pay from savings. Let's circle back to this verify password use case and talk about relationships again. How does verify password relate to the rest of the diagram? Neither of our actors are directly initiating this action. It's just immediately going to happen within our banking app every time there's an attempt to log in. This is an include relationship. An include relationship shows dependency between a base use case and an included use case. Every time the base use case is executed, the included use case is executed as well. Another way to think of it is that the base use case requires an included use case in order to be complete. When you have an include relationship, you draw a dashed line with an arrow that points towards the included use case. So in our example, login is the base use case, and verify password is the included use case. Every time a customer logs in, our banking app will automatically verify password. This login use case won't be complete unless verify password is complete. So we draw a dashed line with the arrow pointing towards the included use case, and we write include in double chevrons. The next type of relationship is the extend relationship. An extend relationship has a base use case and an extend use case. When the base use case is executed, the extend use case will happen sometimes, but not every time. The extend use case will only happen if certain criteria are met. Another way to think of it is that you have the option to extend the behavior of the base use case. When you have an extend relationship, you draw a dashed line with an arrow that points towards the base use case. In our example, login is a base use case, and display login error is an extended use case. Our banking app won't display a login error message every time a customer logs in. This will only happen once in a while when a customer accidentally enters an incorrect password. Since this is an extend relationship, we draw a dashed line with an arrow that points to the base use case and write extend between double chevrons. Hopefully, this thoroughly explains the difference between include and extend relationships. But just in case, here's a very basic example to help differentiate between the two. If you sneeze, you will close your eyes. That's an included relationship because it's going to happen every time. Additionally, if you sneeze, you might say, excuse me. That's an extended relationship because it supplements the sneeze, but isn't completely necessary in the sneezing process. Just remember that include happens every time, extend happens just sometimes, and don't forget that the arrows point in opposite directions. One quick thing to note is that multiple base use cases can point to the same included or extended use case. For example, both transfer funds and make payment are going to point to verify sufficient funds as an included use case. We want our banking app to make this check every time either of these base use cases occur. You don't need to duplicate the verify sufficient funds use case. The simpler your diagram, the better. The last type of relationship we'll discuss is generalization, also known as inheritance. When you make a payment from our banking app, you can do so from either your checking account or your savings account. In this scenario, make a payment is a general use case, and pay from savings and pay from checking are specialized use cases. You could also use the terms parent and children. Each child shares the common behaviors of the parent, but each child adds something more on its own. To show that this is a generalization, we draw this type of arrow from the children up to the parent. You can have generalizations on use cases like we have here. You can also have generalizations with actors. In certain scenarios, you might want to distinguish between a new customer and a returning customer. You can make them both children to a general customer actor, which would allow you to have certain behaviors or qualities unique to each of these children. One last shape that we'll quickly talk about is a use case with extension points. You can see an example here. The name of the use case is above the line, and then there are extension points below the line. Extension points are just a detailed version of extend relationships. This use case shows that a customer can set up their profile in our banking app. And then these extension points show us that when a customer is setting up their profile, they'll have the option to navigate to a couple different screens. If a customer is confused, they can go to Profile Help. And if they want details regarding their private information, they can go to Privacy Info. Those extension points branch off to extended use cases. Go to Profile Help and show Privacy Info. We can even add a note to show what sort of conditions would lead to these extension points. Now we have a complete use case diagram with various elements that help explain what our banking app does. This is a very basic example, but remember that even complex systems should be restricted to a simplistic visualization of functionality, behavior, and relationships. If you'd like to take a closer look at this example, click on the card in the upper right-hand corner. You'll find this exact banking app example plus several other examples and resources. Thanks for watching this tutorial on UML use case diagrams. Please subscribe to our channel to...
So if you look on this one, you see that it's very simple diagrams. Normally you work during the brainstorming. So very simple to see how the interaction between the character together. And if you, let's see, this one here. Okay, so come back to this one. Okay, so for this one, you have to create the unified modeling language. You use a draw.io here. I see it's a draw.io. So first one, you download this one here. I see already have some kind of template. So we download it and you store it to somewhere. Okay, you download it, you store it somewhere. I already let me see. Okay. I already downloaded it. So you can go the first once you download, you go to draw.io here. So you open the existing diagram and you will locate it. I draw it and sorry, I download it and store it in here. So I open it here. Okay, so in that one, you will have the system here. It's a school registration system. And you have the actor here, the actor and actor here. And you can change the actor, you can change the actor name whatever you want. You can change the actor name whatever you want. Sorry. Why? Okay, so it should be a student, right? This one should be student, and this one, I think it should be the register or something like that. Right? So basically, for this one, you follow the program here. Sorry, instruction here. You can use a use case in that. You have some the tool for the includes the extend and the generalization here. You can use a use case here. So you see in that one, you have the sum of the tool, you have something with the communication part, you have the include, you have the extend, and you have generalization here, and you have the character here. So So we can change the name of character, and you just draw some of the conversion in that one. I'm not really sure how the school registration works, so it's up to you. The thing is, you can log in, or you can work with Ivy advising or something like that. I'm not really sure about that, so it's up to you. It's totally up to you here. You can draw and you can working with the include or extend or generation here. It's totally up to you. Okay, and what else? Okay, so when you're done, so when you're done with this one, remember that you have to save it. You have to save it, save that, and you save it XML here, and you save it somewhere, and after that you just submit the file here. Okay. I have to honestly to say I don't have much experience working with this one because the software development is not my major. But for this one, very simple. So I think you are able to do it by yourself here. Any question for us? Let me know.
I'm good.
Okay. So what else? What else? You have the quit here. You already done the quit last time, right? What is it? Yes, it's already did it last time. You have a checkpoint. What is a checkpoint here? Checkpoint is enter the username and password. Is very simple. Sorry, username and sorry, enter the first name and last name. Okay, so now we go to the homework assignment here. And remember one thing from this week, right? From this week here, you have to work on the progress report. Some of them they are not graded. For this one is not graded, but again, I strongly recommend you to working on the weekly basic here because it's quite a huge project. So if you wait until the last minute, I afraid that you have a lot of things to do and should work from now on the weekly basic progressively here. And for the homework assignment, the first one you have to base on the reading, discuss the software development life cycle, and relate to the creating the software that calculates the total and dispatch chain for the cash register at the local grocery store here. Okay, so now think about this one. Let me come to this one here. Okay, so if you remember about the software development life cycle, you have perform the step, you have analyze, you have design, you have the coding, and you have starting here. Right? So now think about the program here. You have to create the software that calculates the total and the depend chain for card register at the local grocery here. So if you look on the requirement here, let me open the word here. Okay, so if you look on this one here, you have to calculate the total and the depend chain. So what do you think? What are the expected output here? The first one you have to working with LLI, right? LLI here. So in the LLI here, the first one you have to identify what are the expected output and on what are the input here. So what do you think? If you look on this one here, what do you think? What are the expected output for this one?
The amount of change dispensed and the total of all the items.
Okay.
The total price of all the items.
Okay, so you have the total, right? You have the total and you have the what is it? The chain, right? And okay, the chain.
Yes.
So it's up to you. You can use a name variable here. Total, it's okay, or you can use a name to change here. It's okay. All right. So now you will have the expected output here. So what do you think? What is the input here? What are the input here? In order to figure out the total and in order to figure out the change.
The prices of each item.
Okay, so the price, right? The price. So I think it's the price of each item. I think to make it simple, right? To make it simple, I think that you buy one item here. So we have the price here, right? So once you have a price, in order to figure out the total, you add it with the tax here, right? So we have the pi, and you have the tax, right? So from the price and the tax, you are able to figure out what is the total here, right?
Mm-hmm.
Okay. So now come back to the chain. So in order to figure out the chain, what do you need here?
Like the amount of money paid.
Yes. Think about if you bought something about if you bought something about 80 $80 here, and with the if you add the tax with the tax about the $5 here, and so in total you have the 58, right? And now if you put the amount paid, amount paid is something about the 100 here, right? So see, you already have a price, you have the tax, you have the price and you have the tax, and you have the amount paid here. So the total from the price and tax, you have the 85, and you have the amount paid 100 here. You're able to figure out what's the change, right? By the deduct from 100 to 85 here, you have the chain here. So now you already figured out the expected output is the total on the chain, and the input are the price, the tax, and the amount paid here. Right. So the next one, you also have to figure out what is the formula, right? So we have so in order to figure out the tax, you have to tax equal to price time 0.07. It's a 7%, something like that. And after that, you have total. Yeah, total equal to price plus tax here. So now the chain, you have the chain is amount paid minus total. So we see that everything in the analyze process here. You see, you have to identify what are the expected output and what are the input, and you have to name a variable, and you have to identify the variable data type. All of them, I think, is a float here. And after that, you have to figure out what are the formula. So now the next step is the design here. The next step is the design. So in the design, it's actually for this one very simple, right? This one is very simple. So you can write on the pseudocode, or for this one you can, if you want, you can break it down into the modular structure, right? So you see you have main module here. You can break it down. It's up to you. You can break it down in 3 submodule or 2 submodule. It's up to you. But it's very simple. So we can have the input. So we can have calculation or something like that, and you have output here. This one is very simple. So basically for the design, you don't have to do much for this one. And or you can work on the pseudocode, or you can work on the flowchart. It's up to you. Or I'm not required for that. It's very simple. Now the next one is that the coding. The coding is just do it on the router here. And let me see, what is it? Okay. So one more thing when you're working with the design. So right. So one more thing I forgot about the design. The design, you also have to figure out the testing scenario. This one here. It's a design here. You also have to figure out the testing scenario. So you have to think about, if you have to think about when you enter the price is 80 here, right? And by working with the tag, you should have the tag here is 80 times 0.07. You have the 5.6 here. So in that case, if your amount paid is amount paid here, you give him is 100 here. So basically the output you expected will be, the total will be the 80 plus tax here. So we have the total you expected here will be the 85.6, and the chain you expected to what is 100 minus this one, you will have the 14.4 here, right? So that is a testing scenario. So you have once you coding, you have to test what happened if you enter the price 80 and the amount paid here 100 here. So the output, the keeping out here is must be the total is 85.6, and the chain here is a 14.4 here. That is a testing step you also have to figure out during the design here. So when the last step here, when working with the testing, you just to make sure that the program here is works exactly as you expected here. Okay, that is very simple for this one. So now you move to the Raptor. You have the 3 Raptor challenge here: number 1, number 3, number 5, and remember that you have to use the modular programming here. So modular programming for this one. So let's see what you have for number 1. What is the number 1 here? Sorry, what is this? This one and this one, right? Let me go back to this one. Here to see.
It was like page 177 or something.
Okay, so let me see what it is. Title. Okay, so for this one, you prompt for an input and sale program $19 commission rate. I'll put her commission for this month. Note that you need to convert percentage to decimal. You need the following variable. You need the following formula. Okay. Sorry. I'll come back. Cháu cũng không phải, cháu đang dạy thì bác ạ, tí nữa cháu còn lại cho bác nhé, cháu đang dạy học. Okay, so if you look on this one, What do you think? What are the expected output and what are the input here? What do you think?
The input.
The first one is output, right? What are the expected output?
The output. The output is her commission earned.
Yes, that's all, right? That you see, if you look on this one, it's only the output or commission, right? For that one, so the only output here is the commission earned. Okay, so in order to figure out the commission earned, what are the input here? You need the sales amount and you need the commission, right? That's all, right? So for this one, you see basically in the analyze process, you have to figure out the commission earned is output and the input as the sales amount and commission rate, right? And you have the formula here already, right? So it's very simple. If you're working with the Raptor for this one, where am I Raptor?
Professor, well, there's a little bit of an inconsistency like between the Canvas, the assignment page and the Word assignment. So the Word assignment says that I'm supposed to do programming challenge 2, 4, and 5, but the assignment page says I'm supposed to do 1, 3, and 5.
Which one is this?
So
1, 3, and 5 here.
Yeah, but try to open the homework assignment. Yeah, yeah.
Ah, okay. I got it. Okay, so I have to modify this one.
Yeah, this one says 2, 4, and 5.
Okay, so I think should be better. I delete this one. Delete this one here. Thank you for notifying me. Okay, so now we come back to this one. I don't know what this is. Yeah. So now if you look on this one, basically it's up to you, right? This one you have to work in the modular structure. It's up to you. You can break it down in input, processing, or output, or you just break it down in input and the output whatever it is. So for this one, you need so for example, for this one, I need to break it down into the input and the output only. Right? So I have the first one, I have the user code here. I put it here, the input.
So I'm supposed to do 1, 3, and 5 then?
Yes, 1, 3, and 5.
Okay.
Okay.
Yeah, because I did 2, 4, 5, so I need to do it again.
Okay, so now we have the input and we have now we have the already function, the module of input here. So if you come back to this one, you need the two input here, the sales amount and the commission rate. So you need two inputs. That's why you have one input and you have another input here, and enter what?
Sales earn.
Sale amount, right?
Yeah, sale amount. Yeah.
Sale earn is output, right? And there's a sale amount. Yes. So you have the variable name. What is the name? Sales amount here. Yes, that's the first one. The second one to enter the commission rate. What's the name? Commission rate.
Don't you also need like another module for processing? Or
it's up to you. I said that when working the modular structure, it's up to you. You can break it down into 2 or 3 or 4 or 5, whatever it is, providing it is convenient to you. You not always have stick to the input, processing, or output. It's totally up to you, right? Providing that it is convenient to you. Okay. And basically for this very simple program, normally you don't have to break it down in the modular structure. The only thing that they require you to work into modular structure for this one is that you have the better understanding how it works with modular structure. So it's very, very helpful you when working with in the next chapter or when working with the final project here. All right. That's all.
Okay. Thanks.
Okay. Okay. So for this one, you can store it, you can save it. This one, commission here. Okay. So now you already have the input, and now for this one, I don't want to do with the processing. I just have the output here. So I call here is the output. I save his output here. It's up to you. You can use the calculation. It's up to you. Yeah. So in the output here, I just combine the calculation and the output into one single module here. So for this one, I have to do everything with the calculation first. I have the commission rate here, right? Commission rate is this one here. So I have to do everything with the calculation. I have what is it? What's the name? Commission earn, right? Commission earn here. I set it equal to sale amount times commission rate divided by 100 here, because you have to change it to decimal here, right? That's why you have to convert it by divide by 100 here. Okay, so this one is calculation. Now I do with the output here. I just print it out. So you have commission earn selling up. What is this? A sale amount. To make it more sense, what the output is the dollar price here. Commission. Yeah, right. Commission. Okay, so we look on this one. For this program, I break it down into two submodules: input and output. And the input, you got everything from the sale amount and commission rate. For the output, I have to do everything with calculation and bring out the output here. Now you can run it. All right, so now see what's the amount here, 80 here, right? And the rate here is a 7%. What's it? Sale
Yeah, you misspelled that variable wrong. It's
okay.
Sale amount, not sales amount.
Yes. Anyway, that is a good example, right? You always have to consistent with the variable name. Otherwise, the program is not running here. So this one, right?
Yes.
Your amount S here.
No, you put the S after sales.
I got it. I got it. Thank you. Sale here, amount here. Okay, so now I run it again. I have 80 here. I have 7%. Sorry, I have a 7% here. Oh my God. I have, okay.
Oh yeah, you misspelled that too.
Yeah, that's the one here. $87. Okay, so we see you have the commission earned after the selling of the 80 is what is it? Oh, sorry. Oh yes, commission earned. Yes, correct. That is correct. Okay, so that is a very simple example when working with this one here, that commission hand here. So you can do the same with number 3 and number 5 here. Do you need me? If you need my help, let me know. I can work with you. And if you don't, just do it by yourself. It's up to you. Do you need my help for that? Let me know.
No.
Okay,
Yeah,
so
I'm good.
you're good, right? Okay, so any other question from you? Let me know.
Nope.
Okay, so one thing about this one, remember that you have to starting with you have to working with you have to working with the progress report here. Right? So see what is the progress report for this one. Okay, so this one is the first project here. Okay, so if you look on this one, in the look on this program, what do you think? What are the expected output here?
The account balance.
Yes. So actually, the account balance here, it is both input and output here, right? So at the beginning, you have to enter the initial account balance is 2,500 here, right? Okay. So what do you think? What are the input here? What are the input?
Username.
Yes. Anything else? Customer.
The amount of money deposited.
Yeah. You need the deposit also, right? So basically, for this one, you have one output here. It's our account balance, and you have 4 input. You have the customer, you have username. Again, you have the account balance, initial account balance, and you have the deposit also. Right. So after that, after the chain here, basically, and let me use what's the word for this one. So you have the one output here. Account balance. Right. And you have 4 input. You have the username, you have customer name, you have a account balance. That is the initial account balance here, and you have deposit, right? And that you have one output, 4 input, and you have formula also, right? So you have the account balance here. That's the new account balance, right? Equal to what? What do you think?
Is it account balance? Wait, no. Is it account balance plus deposit?
Yes, that's all, right?
Yeah.
Okay, so you think about at the beginning. At the beginning, you have the account balance here is 2,500, and if you deposit 100, the new account balance means the 2,600 here. Right? So that's one very simple here. This one, but anyway, strongly recommend you to work in from now on the weekly basis here. Okay, so basically that's all for this week. If you have any question, let me know. Any other question, let me know.
No, I'm good.
Okay, so if you don't have any question, I can stop the class from now. And remember, anytime if you need my help, if you have any challenge with the homework, you just send me the email here. Okay. So no question from you. I'll see you guys on next Tuesday. Bye, guys.
All right. Thank you.
You're on.